In this video, I'd like to show you this robotic arm that I built. Everything was made using 3D printed parts and just hobby servo motors. I do this on the side. I'm no expert in robotics myself, but I just wanted to see if I could build something like this. And I'm pretty happy with the results that I got. And if you want to build something similar to this, I hope this video is going to be useful for you to serve as inspiration and to hopefully give you a few things that I learned along the way so you don't make the same mistakes as I did. I split this tutorial into several videos, otherwise it would be too long. But essentially the goal is for you to learn robotics by doing, either by building this physical robot yourself, or if you don't want to deal with the hardware, this project also has a simulated robot, so you can pretty much just follow along and launch a 3D simulation that matches exactly the physical robot. This is a 3 degree of freedom robotic arm, which means there's 3 independent ways of moving this arm. And what that means is that we can reach any point in space given the constraints of this robot, but we cannot control the orientation of the end effector here. We can pretty much just reach one point in space given the arm in one position with the elbow down or with the elbow up. That's different than 6 degrees of freedom robots that you see in factories, for example. Those, they can also reach any point in space, but in any orientation of the end effector. So you have more flexibility, allowing you to avoid obstacles, for example, or get into very specific and difficult orientations. For this project, I mounted the robotic arm on top of this RC car. That is another project that I was working on, but I pretty much just did it because I needed a heavy and sturdy base for the robotic arm. So feel free to attach this to anything else. As long as it's very sturdy, it should be fine. But for this video, take this robotic arm in isolation. We're only going to be looking at this part over here. So let's talk about the things you need to build something like this. As you can see, most of these parts are made out of 3D printed parts, so of course you're going to be needing a 3D printer. And again, it doesn't have to be a fancy one. Mine is also a simpler model. And for these parts, we don't need extremely fine details or very nice surface finishes. We just need functional parts. So most 3D printers are going to be fine. As I mentioned, we're going to be needing 3 motors for this project, one for each degree of freedom. And I used the ST3215 servo motor, and that's the first lesson that I learned along the way that I would recommend to you, is to not really cheap out on the motors. And so I decided to upgrade to these buzz servo motors. I realized that they were very precise and they are very strong as well, which are very important for a robotic arm like this. Now, to control this, you're also gonna need a computer, and that can be anything. That can be a laptop, a desktop computer. In my case, I decided to go with the Raspberry Pi because, as I mentioned, this robot is mounted on this RC car, which was another project of mine. And using a Raspberry Pi here on board was just easier for me. But that is all that I have for this introduction video. In the next part, we'll be talking about the math behind a robotic arm like this and how we can use high school geometry to find the angles of each motor to reach a certain point in space. Thanks for watching.